Hi everyone, welcome back. Today we'll be looking at standard 6.EE.A.2c, evaluate expressions at specific values for their variables. An algebraic expression is a mathematical sentence consisting of variables, numbers, and operations such as multiplication, division, addition, and subtraction. Expressions do not have an equal sign. For example, 4x minus 3. Algebraic expressions can be simplified by plugging in a given number for the variable. So if we look at this expression here in the function machine 9x, this is 9 times x. If I plug the number 5 into the expression, it becomes 9 times 5, which provides the output of 45. Example 1. Evaluate the expression for x given that x is equal to 7. So I'm going to go ahead and write the expression for x. And then I'm going to replace the x with a parentheses. Now the parentheses is really important, especially when we're doing a multi-step problem, because it shows what operation needs to be done with the number. So I'm going to plug the number 7 in. 4 times 7 is 28. Now a common misconception is to think that this is 47. It is not. It's 4 times 7, just like this is 4 times x, which is why we have an answer of 28 and not 47. Find the value of the expression a minus 3, where a is equal to 15. So I'm going to always use my parentheses when working with a variable just because it helps to keep my work organized. Now I have, and I can rewrite this without the parentheses, 15 minus 3 for a final answer of 12. So the expression a minus 3 when a is equal to 15 is 12. Here we have some examples that require us to do more than one step. So we need to reference our order of operations, right? Our grouping symbols come first, then our exponents, multiplication and division from left to right, addition and subtraction from left to right. Number 3 says, evaluate the expression 3m minus 5 given that m is equal to 6. So I'm going to substitute my m for parentheses and plug the number 6 into it. Now this is 3 times 6, again not to be confused with 3 and a 6, which would give us 36. So this is 18 minus 5. 3 times 6 is 18. I bring down my minus 5. 18 minus 5 is 13. Our next example is f divided by 5 plus 2. It says that f is 25, so I'm going to go ahead and substitute that in. So 25 divided by 5 plus 2. Order of operation tells me to divide first and then add. 25 divided by 5 is 5 plus 2. 5 plus 2 is 7. So that's my simplified value of this expression. Here are some additional expressions that require multiple steps. Find the value of the expression b times a plus 3 minus 7 when a equals 2 and b equals 4. Okay, so I'm going to replace my b with the number 4. My a is 2 plus 3, and then minus 7. Order of operations, I have to do what's inside the parentheses first. So 2 plus 3 is 5. And then I have 4 times 5. So when they're in parentheses next to each other like that, that's multiplication. 4 times 5 is 20 minus 7 for an answer of 13. Our next expression, 91 minus u divided by 3 squared. Fraction bars are like grouping symbols, so I have to do what's on top first, what's on the bottom, and then divide. So let's go ahead and substitute. So 91 minus 10 over 3 squared, and I can rewrite this without the parentheses because there's no multiplication there. And then 3 squared is 9. 91 minus 10 is 81. 81 divided by 9 is 9. And our next example, so here we have two variables next to each other, which again is multiplication. And then I have a variable being raised to the third power. So let's go ahead and plug in. When I have a problem like this is where the parentheses really, really are important because it's going to ensure that I complete my operations in the correct order. So I'm going to put two sets of parentheses, and I'm going to put for x 6 and for y 2. And then I'm going to write my 2 to the third power. So all of the 2 is being raised to the third power. 2 times 6 is 12, and 2 to the third power is not 2 times 3, it's 2 times 2 times 2. 2 times 2 is 4 times 2, which is 8. So now I have 12 minus 8, which is 4, and that's my final answer. Thank you for watching and have a great day.